we are looking at the factored form. Okay? So the opposite of expanding, so the process of expanding, if you remember that what we did before, we did the expanding, which is either like if I had a monomial by a binomial, right? And we did the expanding, we did multiply, or if we had the two binomial multiplied together and then we had to FOIL, right? This is called the expanding process. Today what we're going to do, we're going to do the opposite of that, okay? So we're going to go to the opposite of expanding, which is factor. So the process of going from the standard form to the factored form, it's called factor. Okay? So going from standard, which the standard form look like y equals ax squared plus bx plus c, where a, b, and c are numbers, and a cannot equal to 0. To factored, which is y equals ax minus r x minus s. The whole process going from this to this, it's called factor. Okay? Now what we've done already, we've done what we going from factor to standard, which is expand. Okay? So we're going the opposite way today. The first thing we're going to do with factoring, we're going to learn 3 different types of factoring. Okay? We're going to learn common factoring. We're going to learn how to factor by difference of squares, and then we're going to learn how to factor by sum and product. Now there is another type of factoring which we don't learn in this particular course, but I can go over a couple of examples. You won't be tested on it. I'll give you a couple of examples just for the people who would like to know a little bit more. Okay? But we will not be tested on the extra, on the okay? So the first thing we're going to start with is the greatest common factor. Okay? So a greatest common factor or GCF, okay, so that's the acronym for it, so GCF. So the greatest common factor, or the GCF, is an expression that can be divided into each term in a polynomial. Okay, so you look at your polynomial, you look at all the terms, and then you're going to find a common factor, a number or a letter that I can divide each term by. Okay. Always we start with the greatest common factor. The first thing you always have to think about, do I have a greatest common factor? If you do, you have to factor it out first. Okay? So if I'm looking at this trinomial here, I have 9x cubed minus 15x squared plus 3x. What would be a number that you can divide all 3 terms by? 3 is 3. Right? So the number is 3. Now, you see that in each term, you have the letter x, right? So that means also you can factor out an x. So now I can factor out a 3x. So that would be my greatest common factor. Okay? So I identified my greatest common factor, which is 3x. I have to factor it out, and I have to divide each term by that 3x. So the process is like this. Identify your greatest common factor. So I know my greatest common factor is 3x. Right? You're going to write the 3x on the outside. And then I'm going to start showing you how you're supposed to write it, but then we will be skipping that step. Okay? I'm just going to show you what happens when you factor that 3x out, but we're going to be skipping that step. Okay? In the later, like in other examples. So you're going to take each term, and you feel free to show me that step if you want. Each term is going to be divided by your greatest common factor. Each term is going to be divided by the greatest common factor. Okay? So what we do, we put put the greatest common factor outside. We divide each term by that greatest common factor. Are we okay with this? Okay? So what would my answer look like? My answer would be the following. My greatest common factor outside, bracket, and then we're going to look at how to divide each term by 3x. So what's 9x cubed divided by 3x?
3x.
3x squared, right? 9 divided by 3 is 3. X cubed divided by x, you subtract the exponent, so 3 minus 1 is 2. 15x squared divided by 3x. 5x. And then 3x divided by 3x.
1.
1. If you divide something by itself, it's 1. Okay? So you see, right? A lot of people, and this is why I write this, a lot of people, they stop writing the GCF outside, which is wrong, because then you're changing your equality. Make sure you have your GCF outside, and it's multiplied in the bracket with your, what we call the leftovers, right? When you factor the 3x.
Should we add the 1, right? Should we add the 1?
Yes, the 1 should be there. Yes, because otherwise, because if I want to go backward, right, if I want to expand, I need to be able to multiply each this, and I should come back to my original, right? If the 1 is not there, then I'll be missing a whole term, right? So if you want to test your answer, you can always do the opposite operation, which is the expanding, to see if you actually get what you started with. Okay? Are we okay with this? Now, something that you need to note is if your first term, or the highest degree, has a negative in front of it, you must factor a negative out. Okay? So if I have, for example, like C, it's negative 54x4 plus 135x. This term, which is we call that the leading coefficient. Okay? Let me just write that down. So when I have trinomial, binomial, whatever, polynomial, okay, and let's say I have negative 4x squared plus 3x plus 5, okay, that's an example. The coefficient of your x squared, which is your highest exponent, that coefficient right here, this is called a leading coefficient. And the rest are called just coefficients, okay? This is called the leading coefficient, okay? Because this is the coefficient of your first term. Technically, this is how the term should be written in order of highest degree and so on, right? Highest degree, lowest degree, and then no degree.
So it means we have to change the mark inside, right?
Yes, so when you factor a negative 5, whatever the negative that you're going to factor out, it's going to affect your sign of this one. Okay? Let's look at the first term, the first example, example 1a. What would be my greatest common factor? 4x squared, right? So, eyes on me for a second. You're always looking at that each term has an x in it, and then you're looking at your exponent, okay? You're going to always take out the lowest exponent, okay? So it's going to be x squared in this case. Okay? And then 8, 4, and 20, they're all divisible by 4. So I can take out 4x squared. Okay? Remember I told you I'm going to skip the middle step? So I'm going to skip writing this step. Okay? So you're going to divide each of these terms by 4x squared. Okay? What's 8x4 divided by 4x squared? 2x squared. 8 divided by 4 is 2. X4 divided by x2 is x2. We're good with that? Yeah. Okay? 4x cubed divided by 4x squared, or negative 4x cubed divided by 4x squared?
Negative 2x.
Negative x. 4 divided by 4 is 1. X cubed over x is, over x squared is x. 20x squared divided by 4x plus 5,
That's 5.
just 5, right? There is no more x. Okay? As of now, we're only doing greatest common factor. We haven't gone into the other types of factoring because I want you to know how to do the greatest common factor first, because that's always our first step. Okay? You always have to first look for a greatest common factor. What will be your greatest common factor for the next one? 25. Any x? No. Because my second term does not have an x. So 25, and if I divide each one by 25, x squared minus 4. Okay? Now remember, I'm only doing greatest common factor. I can factor this further, but you haven't learned how to. We'll talk about that in the next lesson. Okay? How about
7x.
negative?
Negative 9. You want 9x?
We have to take the negative out. Okay? So it's going to have to be negative. If you're looking at 54 and 135,
Is that 9?
9, you would still have more factoring to do, right? Because if you factor out a 9, okay, factor out a 9 or negative 9, right? Let's look at 9 first. If you divide 54 by 9, what do you get?
6.
And then if you divide 135 by 9, what do you get?
15.
15. Is there another common factor between 6 and 15?
Yes. 3.
There's a 3. So this is 9 is not my greatest common factor. It's a common factor, but it's not the greatest. Okay? So if I'm going to take another 3 out, 9 times 3 gives me 27. Okay? So that's why I know that my greatest common factor is 27. Okay? So if that's what you think it's 9, look at the numbers, right? And then see, can I factor something else still from the numbers? You're going to find out that yes, you can factor a 3 out. Then you're going to take that 3 and multiply it by what you factored out. Okay? So we know it's going to be negative 27x. Why negative? Because my leading coefficient is negative, and I want to factor it out. So it will be 2x cubed. Yeah.
Negative 5.
What?
So my question, if I didn't find this greatest, can I write down the 9 and factor
Yeah.
again? It's
Yeah.
not going to be more.
Nope. You're doing it in 2 steps.
2 steps.
As long as you pay attention to your answer and then you know that your answer still is not factored completely, right? Because if you do that and then you write this for me, right? It was 6x cubed minus 15, right? If you leave it like this, that's not your final answer. Okay? So you haven't completely factored, because when I'm asking you to factor, I'm asking you to completely factor. Okay? Now, if you pay attention to your factor, to your leftovers, and then understand that, well, no, I can still factor a 3 out, and then factor it out, right? That's fine. You can do that.
Oh, like this.
Yeah,
And
because
that's
you're going to factor a 3 out. What's 3 times negative 9? You're going to have to
No, I
simplify.
need to factor it with 2, what is called binomial,
Yeah?
2 brackets.
No, it won't be 2 brackets. It won't be. It won't be.
2 brackets. 15. Oh, you can't.
It
you
won't
can't
be.
divide
No,
15
you
by
can't.
2. Okay. Yeah, sorry.
You can.
Yeah, the 9 you can, but 15.
Okay?
Okay.
Are you okay with the greatest common factor? It's gonna take some practice. It's always your first thing you're gonna look at. Questions? Can I go to the next type of factoring? So if you look at that green sheet that I've given you, at the back of the green sheet, there is your perfect square numbers. Okay, so 1 squared is 1, 2 squared is 4. You're going to have to complete this one. You need to get yourself familiar with these numbers because these are your squared numbers. These are your perfect square numbers. Go back a bit. You have that? Okay. So get yourself familiar with these ones, especially like at least up to 12 squared. So this way when you see them, you recognize them. Okay? The only one that I always don't recognize is the 8 squared for some reason. You don't have it? You can take that one. So a number is called a perfect square. Okay, I'm going to erase this number. If when square rooted, the result is a whole number, is an integer. Okay? So if you look at 9, if I square root 9, that's going to give me 3. Right? If I look at 16, if I square root 16, that's going to give me a 4. If I square root 25, that's going to give me a 5. So get used to these perfect square numbers. Okay? Because you need to be able to identify them. Okay? The other thing that you're going to have to look for is the letter. How do I know that a letter is a squared letter?
By the exponent.
By the exponent. If the exponent is even, so it's an even number, right? So 2, 4, 6, 2, 4, 6, 8, right? So if the exponent is an even number, then I know that it's a perfect square. Okay? So so if I have x to the power of 8, that's a perfect square, right? Because it's an even exponent. How can I square root that? So what would be my answer when I square root x to the power of 8? The answer is, it's x 8 divided by 2. So how do you find your square root of a letter to the power of 8? You divide your exponent by 2. Okay? So the square root of x to the power of 8 is x to the power of 4. Okay? So you always, whenever you have, let's say, whatever, x to the power of 12, right? To find the square root of this, it's x to the power of 6 because you're dividing your exponent by 2. That's for the letters. For the letters, the exponent. For the regular numbers, right? You're going to look at whatever the number is. So square root of 144, you can put that in a calculator and it will give you 12, right? But for the letters, you can't put it in a calculator, right? But the process is you divide your exponent by 2. Are we good with that? All right. Now, we're going to go to the process called difference of squares. So factoring by difference of squares. When you did your homework with expanding, so go back to your homework booklet for me. And you did the expanding part, expanding 2 binomial, multiplying 2 things. Did you end up, in some cases, with 2 terms when you did the expanding? Did you end up with 2 terms? Okay, what are the terms? So, give me an example where you ended up with 2 terms. Yeah, go ahead.
X squared minus 9.
Sorry?
X squared minus 9.
So that's your answer, x squared minus 9,
Yeah.
right? And then what was the 2 binomial that you're multiplying?
X minus 3, x plus 3.
Okay? Can you give me another example?
X squared minus 16. Sorry.
Did you get that in the homework? Was that in the homework?
Yeah, it's 4x squared minus 81.
4x squared minus 81, and what was the 2 numbers that you're multiplying?
Minus 9, 2x
Yes.
plus 9.
Okay? So Anything that you can compare? You don't need to write this, by the way. Sorry?
All same number except the negative and positive in the bracket.
So there, in the brackets, you have the same letters and same numbers, except one is a negative, one is a positive. Okay? You've noticed that in the second example as well. So it's the same terms, right? But one is a negative, one is a positive. And then when I multiplied, when I expanded, I ended up with two numbers, or two terms for both of them. And what's in between the two terms?
No, square is the first term,
And the minus.
so the second term.
So the first term is a squared term, the second term is a squared term, and
The sign is negative.
is minus.
Minus.
So you're minusing the two. What does the word difference mean? When it comes to operation, what's difference?
Divide.
Difference.
No.
Difference. And they are.
Same.
Difference?
No, the difference by the minus, right?
Minus. Right?
We have minus.
So the difference, the word difference means subtraction.
Subtraction.
Okay? Difference of squares. Okay? So look on the board for a second.
It's difference of
Difference
square.
of squares. X squared is a squared term. 9 is a squared number because I know that. Okay? So I have two squared terms with a subtraction between them. This is a special case here. Okay? It is called the difference of squares. When you factor the difference of squares, so if I give you something that looks like this, where you have two terms, there are squared terms, and there is a minus between them, there is a special way to factor. Okay? Let's look at what the special way is. So, you're going to have to check two things. First of all, it's a binomial, so two terms. Second of all, are both terms perfect squares? So, let's look at this. Is 9x squared a perfect square?
Yep.
9 is a perfect number. X squared has a exponent 2, even exponent. Is my second term a perfect square?
Yeah.
Yes, 16 is 4 squared. Good. So that's my first check. Do I have a subtraction between the two? That's my second check. Okay? So now I know that it's difference of squares. How do I factor that? You're going to put two brackets. Okay? This is the steps that you're going to have in your head. Okay? You don't have to follow these steps, but this is basically what you need to do. You're going to put two brackets. One bracket you're going to put a plus. The other bracket you're going to put a minus. It doesn't matter which one you put first. Then, you're going to square root the first term. Square root of the first term is going to be, what's square root of 9x squared? 3x. So, you're going to square root your first term, and you're going to put it in the first spot in both brackets. Okay? Then, you're going to square root your second term. Square root of 16 is. And then you're going to put it in the second spot. So you're going to end up with two binomials. They look the same, except one is a positive, the other one is a negative. Yeah? Now I can check my work, and I can see, well, on the side, don't check it here, right? So if I do my expanding, 3x times 3x is 9x squared. 3x times negative 4, that's negative 12x. 4 times 3x is plus 12x. 4 times negative 4, that's negative 16, right? What happened here is the negative 12x and the plus 12x, they cancel each other, and you'll be left with 9x minus 16. That's what I started. Okay? So this process is called difference factoring by difference. So what I'm going to do is I'm going to give you some time to write this, okay? And then I'm going to give you time to work on the examples at the